Hey there, welcome to today's video. Today we're diving into a common problem that many programmers face when working with multi-threaded programs. The issue at hand is the excessive use of atomics, specifically on ARM processors, leading to performance slowdowns due to unnecessary fences being inserted, even within loops. We'll explore how memory orders can help eliminate these unnecessary fences and optimize our code. In the solution provided, we first look at examples of code using relaxed loads in different scenarios. The key point to remember here is that relaxed loads do not establish a happens before relationship with release stores. This means that in certain situations, such as the last example provided, the order of stores could end up different in the modification order, potentially leading to unexpected results. However, in real hardware scenarios, due to the nature of speculative execution and store commit to coherent cache, a release store should be sufficient to order the stores correctly. To summarize, while the C abstract machine may not guarantee the safety of using relaxed loads in all scenarios, real-world hardware implementations are likely to execute the code correctly. By understanding how CPUs handle speculative execution and store commits, we can optimize our code effectively. Remember, optimizing for performance is crucial, but always ensure the correctness of your code first. Thanks for watching, and don't forget to subscribe, like, and leave a comment below. Happy coding!